milliliters. All right. All right, so here we are at the last question, which kind of combines several of the other previous stoichiometry problems we were doing. So if this is the only one you're watching, I would recommend you go back and watch 19 and even possibly a few other ones where we were doing either solid stoichiometry or we were converting molarities to moles. So it says, what is the mass in grams of AgCl, or excuse me, what mass in grams of AgCl is formed from the reaction of 75 milliliters of a 0.078 molar silver acetate solution with excess magnesium chloride. And then it gives us a molar mass of AgCl. So essentially what we have here is we have two silver acetates in a double displacement reaction with MgCl2. And we precipitate two silver chlorides because chlorides are generally soluble, but silver is an exception, so it's insoluble. So this is our white precipitate. And we get just two magnesium acetates as spectator ions floating around in solution. So what we need to do is we need to, starting with this volume of this molar solution, so this is both information about this solution, we want to know how many grams of this were formed. So that's our goal. Well, in this case, what we want to do is very similar to what we've done before, which is try to find moles of something, which we can use the balanced chemical equation to convert it to moles of something else, and then we can convert it to grams. And specifically, what we want to do is this silver acetate solution. We want to start with liters of this AgC2 H3O2 solution, and we want to convert it to moles of this AgC2H3O2 solution. We can then convert that to moles of AgCl using the balanced chemical equation. And then we can convert that to grams of AgCl using the molar mass. So that is our plan of attack. Well, in this case, we're starting with 75 milliliters. We don't want to start with milliliters. We want to start with liters. So divide that by 1,000. 0.0750 liters of AgC2H3O2. And we want to convert that to moles. Well, we need to use the molarity to do that. In every 1 liter of this solution, there's 0.078 moles. So we put the 1 liter of the solution, on the bottom, and we put the molarity number of moles, 0.078 moles of the silver acetate, on the top. Okay, so the molarity number of moles on the top, 1 liter on the bottom. Liters will cancel out, and we'll be left with moles of this compound. We can then convert it to moles of this compound using a balanced chemical equation. Specifically, 2 moles of AgC2H3O2 is equal to 2 moles of AgCl. So I'm just using the stoichiometric coefficient in front of each of them from the balanced chemical equation. And now, like we've done many times before, we want to convert from moles to grams. Well, in this case, we're starting with moles, so we want the 1 mole of AgCl on the bottom, and we want the 143.32 grams of AgCl on the top. Multiply by the top, divide by the bottom, repeat until you get to the end. And what you find here is that there are 0.838 grams of AgCl that is formed in this reaction, and you can't see that. So we just multiply by the top, divide by the bottom, and that's what we ended up getting, which is choice letter A. So that brings me to the end of this problem set. And if you weren't sure how to follow along on this one, please watch the previous question because it's kind of very similar to this. So thank you for watching and good luck on the exam.